Hi everyone, this is in continuation to our previous video lecture where we were discussing about effect of electron withdrawing substituent on the acid strength of carboxylic acid, right? And we studied that fluorine, right? When we have fluorine attached to the chain which is directly attached to this chain of carbon atoms, which is directly attached to this carbon atom of carboxyl group. This is an electron withdrawing substituent, so it will withdraw electron density towards itself, thereby making this OH bond a weaker bond, right? Due to which the release of hydrogen ions will become easier. So more hydrogen ions would be released. That means the acid will become a strong acid. Then it will disperse the negative charge, right? It will disperse the negative charge onto this from this fluoroacetate ion. You have less negative on this oxygen now, due to which this ion, fluoroacetate ion, will become a stable ion. So more stable is the ion, more you have hydrogen ions in the solution. Why? Because if this is more stable, it will not immediately combine with this hydrogen ion to give you back this fluoroacetic acid, right? So fluorine, due to minus I effect, will weaken OH bond and stabilize fluoroacetate ion, right? And by dispersing the negative charge. Now there are three things, right, that we did not discuss in the last lecture, that the nature, position and number of this electron withdrawing group, right, will affect the acidic strength of acids, carboxylic acids. And how it does? Nature, by nature we means this halogen atom. We know that halogens are electronegative. So more electronegative the halogen atom is, the more stronger would be the acid, right? So fluorine is most electronegative, so it will attract the electron density more compared to chlorine. So fluoroacetic acid would be stronger than chloroacetic acid, and since chlorine is more electronegative than bromine and bromine is more electronegative than iodine, so chloroacetic acid would be stronger than bromoacetic acid, right? Why? Because if fluoroacid, this is the sequence of electronegativity. If chlorine is more electronegative than bromine, then chlorine will attract the electron density more towards itself with a greater force towards itself. So it will stabilize this ion more. That is, chloroacetate ion would be stabilized more compared to bromoacetate ion, right? Similarly, fluoroacetate ion would be stabilized more compared to chloroacetate ions, right? And when this fluorine will attract this electron density more towards itself, it will weaken this OH bond more compared to chloroacetic acid, right? Now the other point is, we talk about position. We have studied an inductive effect that as the distance of this group will increase from this carbon, right, then the inductive effect will decrease, because this electron withdrawing effect of this halogen atom is due to minus I effect, right, inductive effect. So this minus I effect will decrease as you move away from this carbon atom, right? For example, if your fluorine is here, right, or let's take it like this. If your fluorine is here and in the other acid you have fluorine onto this carbonate, right? You just notice one thing here, the position of fluorine atom has changed. Here fluorine atom is close to carbon, right? Here fluorine atom is away from this carbon. So when the fluorine atom is away from carbon, the minus I effect will decrease, right? When minus I effect will decrease, the electron withdrawing capacity of this fluorine atom from this carbonyl carbon and this oxygen will also decrease, right? When the electron withdrawing capacity will decrease, in that case when this electron withdrawing capacity will decrease, right, due to which this bond was getting weaker and this acid was getting and this hydrogen ion was getting released, right, and this ion was becoming more stable, right, due to minus I effect. But this minus I effect is less when this fluorine atom is away from this carbon. That means this will be less stable. The ion would be less stable and this hydrogen ion release will be more difficult in this case, right, because minus I effect is less when fluorine atom is away from carbon. Now in this case, when fluorine atom is close to carbon, you have minus I effect will be more, right? So electron withdrawal will be more in case of acid where this halogen atom would be close to this carbon atom. So we say that this acid would be stronger than this acid, right? Acid strength will decrease here, right? This acid would be stronger than this acid, right? This is what it means, right? So due to increasing distance of halogen atom from this carbon atom, right, the minus I effect, right, will decrease. Due to decrease in minus I effect, this dispersal of negative charge will become less and this OH bond, right, will become little stronger, right, due to less minus I effect, right. So it will make the acid a weaker acid, right. I hope this is clear. Now when we talk about number, when number means number of electron withdrawing substituent, it's very easy to understand. One electron withdrawing substituent is withdrawing electron density towards itself, right, due to which this bond is getting weaker, right, and it's dispersing the negative charge, right, the electron withdrawing substituent. Now if I increase the electron withdrawing substituent, right, then if I increase the, let's take a different example. If I have 3 chlorine atom attached to this carboxylic group, then all these chlorine atoms will attract the electron density towards itself, right. Now due to the electron withdrawing effect, right, of these chlorine atom, you have maximum minus I effect, right, because you have 3 groups that have minus I effect, right. So trifluoroacetic acid would be a stronger acid, right, would be strongest acid because it has more number of electron withdrawing substituents compared to dichloroacetic acid, right, and dichloroacetic acid would be stronger than monochloroacetic acid because dichloroacetic acid has more number of electron withdrawing substituents, right. I hope this is clear. This question is important and is asked many times, like why trichloroacetic acid is the strongest acid. The reason is because it has 3 electron withdrawing substituents, 3 electron withdrawing chlorine atoms, which will intensify the negative charge onto the trichloroacetate ions to the maximum, right, and will weaken the OH bond to the maximum, due to which the release of electron will become easier, right, and this, since the trichloroacetate ion is stable due to maximum dispersal of negative charge, it will not immediately combine with this hydrogen ion to give you back the unionized acid molecules, right. I hope all this is clear. Thanks.